All right, you are welcome again. Today, let's talk about calculus. Under calculus, let's talk about inequality. In this lesson, I want us to treat introduction to inequality. All you need to know about inequality. We also talk about the principles of inequality. Then we also take a transitivity law. Okay? We'll take a theorem called transitivity law in inequality. Please, it's very, very important. Please watch this to the end, most especially the transitivity law. Okay, now let's go. All you need to know about inequality, that is what this video or this lesson is all about. Now let's go. An inequality is a statement that one expression is smaller than the other expression or greater than the other expression. Hello. When they talk about inequality, they are talking about a statement that of two quantities, one is specifically less than or greater than another. Okay? A statement that of two quantities that one is specifically less than or greater than another. Okay? Now, hence, the following expression defines inequality. Now, with this, let's also take more definition, that is more explanation to inequality. Now, we say that if A, B, and X are real numbers, then we have something like this. We have the sign A, the sign B. So this sign, it simply means A is less than B. And then we have this. And then this one simply means A is greater than B. All right. Now, when you have something like this, A, it simply means that A is less than or equal to B. Then when you have something like this, it simply means that A is greater than or equal to B. All right. Good. Now, when you have something like this, now, do you see this? Now, this is simply saying that X is greater than A but less than B. Hello. Now, let's take a look at this. If you want to pronounce this, we're going to start from the center to the left and then from center to the right. So that means we're going to say X is greater than A but less than B. Now, let me show you how to read it. Normally, when you have two, like A less than X, we read it A is less than X. But when you say A is less than X, that means that X is greater than A. Is that true? That means we want to read from center to the left. You change it, okay? Opposite of it. That means instead of you saying A is less than X, you say X is greater than A. And then X is less than B. All right? So the expression reads X is greater than A but less than B. Likewise, when you have A greater than X greater than B, so the correct reading of it says X is less than A but greater than B. X less than A but greater than B. All right. But also, when you have expression that looks like this, you read it like this: X is greater than or equal to A but less than or equal to B. X is greater than or equal to A but less than or equal to B. Now let's go. Other properties of real numbers. We say that for all A, B, which are real numbers or which exist in real numbers, one and only one of the following properties hold good. Either A is less than B, or A is equal to B, or A is greater than B. When you pick two numbers from real numbers, you will have something like this. It cannot be 2, it cannot be 3. You only have one and only. So when you pick two numbers from real numbers, the relationship between these two numbers is either, now let's just take A and B. Let's say that two numbers you pick from real numbers are A and B. And they will say that the relationship between these A and B is either A is less than B, or A is equal to B, or A is greater than B. There is no other. Not when you pick two real numbers, the relationship between these two numbers is either A less than B, or A equal to B, or A greater than B. Now let's go. We also say for all A, B exists in R, you see, with A less than B, then there exists C which exists in R such that C is greater than A, less than B. Hello. So we say for all A, B are real numbers, with A less than B, there must exist C which exists in R such that C is greater than A and less than B. Such that C is greater than A but less than B. Alright, now let's go. This property simply says that when you say that a number is less than a number, now let's take for instance, you say A is less than B. That means there must be a quantity in between A and B. There must be a difference between A and B. There must be a number that shows the difference between A and B. That is simply what this property is talking about. Now let's talk about the principles of inequality. Now, number one principle of inequality is that the sense of inequality remains unchanged if each side is increased or decreased by the same real number. When you have inequality, then we say that the sense, the meaning, what that inequality is saying, it remains the same. It is unchanged if you increase or decrease the both sides by the same real number. Okay, so for instance, we have minus 2 is less than 5. Minus 2 is less than 5. Let's decrease this. So when we decrease this, we're going to have minus 2 minus 3. So we decrease this by 3. So we decrease the left hand side, we also decrease the right hand side. So we're going to have minus 2 minus 3 less than 5 minus 3. So minus 2 minus 3 is minus 5. And then 5 minus 3 is 2. You discover that minus 5 is still less than 2. So the sense did not change. Alright? More also, when you decide to increase this by 3. So you increase the left hand side by 3, increase the right hand side by also 3. So we're going to have minus 2 plus 3 less than 5 plus 3. So minus 2 plus 3 is what? 1. And then 5 plus 3 is what? 8. You still see that 1 is less than 8. The sense did not change. More also, another principle of inequality, it says that the sense of inequality is unchanged if each side is multiplied by the same positive number. The sense of inequality is unchanged if each side is multiplied by the same positive number. By the same positive number. All right. Yes. That means, for instance, we have 13 greater than 10. So when you multiply this 13 and then 10 by the same number, the sense remains the same. Okay, by positive real number, the sense remains the same. Now let's multiply this by positive 2. So that means we're going to have 13 times 2 greater than 10 times 2. So 13 times 2 is 26. Greater than 10 times 2 is 20. But what if it's being multiplied by a negative number? What will happen? Being multiplied by a negative number. Now let's take a look at this. We have 13 greater than 10 multiplied by minus 2. So we're going to have 13 times minus 2 is going to give us minus 26. So have greater than, we have 10 times minus 2 going to give us minus 20. So we have minus 26 greater than minus 20, which is wrong. So when you multiply the inequality by the same negative number, the sense will change. When it is being divided by negative number, the sense will also change. Hello. When you divide inequality by the same negative numbers, the sense will change. Now let's go. Number 3, principle of inequality. We say that if A is greater than 0 and B is greater than 0, then A plus B is greater than 0. If A is greater than 0 and then B is greater than 0, so that means when you add A plus B, both of them must also be greater than 0. More also, number 4 principle, you say that if A minus B is less than 0, then A is less than B. Hello. If A minus B is less than 0, that means that A is less than B. Okay. And if A minus B is greater than 0, that means A is greater than B. You get it? Now let's go. Let me show you what it's trying to say in this law. You say that you have two numbers, A and B. Then when you say that A minus B, if it is less than 0, that means that A is less than B. But if it is greater than 0, that means that A is greater than B. Hello. Now let me use two numbers for instance. When you say 2 minus 3, what will it give you? To give you minus 1. So is minus 1 greater than 0 or less than 0? You discover that minus 1 is less than 0. That means that 2 is less than 3. You get it? That means that 2 is less than 3. More also, when you say 5 minus 3, what will it give you? It will give you 2. And then you discover that 2 is greater than 0. That means that 5 is greater than 3. That means that 5 is greater than 3. All right? Yes. Now, let's go. Number 5. Number 5 said that if A is less than B and B is less than A, that means that A is equal to B. If A is less than B and B is less than A, that means A is equal to B. Now let's take the last section. Now let's go. Let's take the theorem, which is transitivity law. Now let's go. You say if A is greater than B and B is greater than C, then A is greater than C. If A is greater than B and B is greater than C, that means that A is greater than C. How can we prove this? If A is greater than B and B is greater than C, that means A is greater than C. How can we prove this? Now let's go. We say that since A is greater than B that means that A minus B must be greater than 0. Now, you say that A is greater than B. That means there must be a quantity that when you say A minus B, that number must be greater than 0. So we say when A is greater than B, that means A minus B must be greater than 0. Also, when you say B is greater than C, that means B minus C is greater than 0. Hello. When you say B minus C, so when you say B is greater than C, that means that B minus C is greater than 0. Okay? Now, A minus B, which is greater than 0, plus B minus C. Both of them, when you join them together, definitely must be greater than 0. Okay? Good. Now, from this place, let's open the bracket. We're going to have A minus B plus B minus C. So minus B plus B is going to give us 0. So we're going to have A minus C. So we'll say A minus C is greater than 0. So, and then we'll say that if A minus C is greater than 0, that means definitely A is greater than C. If A minus C is greater than 0, that means that A is greater than C. All right? We say hence the proof. This is the transitivity law. We say if A is greater than B and B is greater than C, then A is definitely greater than C. And then we have proved this. All right? Yes, please listen to this all over again. Thank you.